Hello students, welcome to my channel Positive. Today's topic is Coulomb's law. Coulomb's law and point charge electric field due to potential. You can say. Dear students, in the physics, there are the two most natural law. One is Newton's law of gravitation and other is a Coulomb's law. When I say natural law, I mean to say that these laws do not have any mathematical derivation, but they are just by the experiments, by the experience of generation, these laws have been derived. Actually, when I say that these laws are the result of experience of generations, I mean that it is not only the Newton or Coulomb. Even before the Newton and Coulomb, people were known to the fact that masses or charges used to have some force between them. Like so. Dear students, Newton's law of gravitation is true for the mass bodies and Coulomb's law is true for the charged bodies. When we talk about Newton's law of gravitation, we used to say that what is the role of Newton's law in physics? Then for me, the mechanics begins with the Newton's law and ends with the Newton's law. But today's our topic is a Coulomb's law. What is means of Coulomb's law? What are the results of Coulomb's law? What are the limitations of Coulomb's law? Dear students, as I have said, the Coulomb's law is the force acting between the charged bodies. According to this law, first this law is true for the point charges. When you say point charges, I mean to say the electron, proton, like so on. Even atom is not a point charge because atom is a combination of number of positive protons and electrons. So you cannot say that atom is a point charge. Okay? So, dear students, what is the Coulomb's law? Let the two charges are Q1 and Q2 and they are a smaller distance away from each other. We are going to discuss the Coulomb's law, dear students. What I have supposed, let the two charges are Q1 and Q2 and they are separated by a distance smaller. According to this law, the force acting between the two charges is directly proportional to the product of charge and inversely proportional to the square of distance between the two charges. So we can say that F is proportional to Q1, Q2 and F is proportional to 1 by R square. That the force acting between the two charges is directly proportional to the product of charge and inversely proportional to the square of distance between the two charges. Now, if you will combine these two laws, you will get F proportional to Q1 Q2 over R square, or F is equal to, when you remove the proportionality, you have to multiply with the constant. Let that is K, Q1 Q2 over R square. Now, the value of K in this case is K is equal to 1 upon 4 pi epsilon naught and its value is 9 into 10 power 9. So, you can write, so F becomes 1 upon 4 pi epsilon naught Q1 Q2 over R square, where epsilon naught is called permittivity of free space and its value is epsilon naught is equal to 8.86 into 10 to the power minus 12 Newton into meter square over Coulomb square. Dear students, I have written that F is equal to 1 upon 4 pi epsilon naught Q1 Q2 over R square. 1 upon 4 pi epsilon naught is a constant. Its value also to be 9 into 10 to the power 9. Epsilon naught is a value of epsilon naught is 8.85 or 6, 8.85 into 10 power minus 12 Newton into meter square or Coulomb square. It is not that I am saying that mug up the unit of that. You need not to learn, just by your common sense you can find the value. Epsilon naught take like this. Oh sorry, it will be, the unit will be epsilon naught bring like this and force will be here. So it is Coulomb square, Coulomb into Coulomb square over Newton into meter square. This would be the unit. Let's discuss, dear students, as I have said, this is two other point charge. The force acting between the even charges, I mean to say between positive, between negative, that is repulsive, and the force acting between the odd charges is adhesive or attractive. Dear students, this formula is true for vacuum or in air. This formula is true for the vacuum if the two charges Q1 Q2 are separated at a distance small r, then the force acting between them would be F equal to 1 upon 4 pi epsilon naught Q1 Q2 over r square. When the charges are kept in vacuum, the value of 1 upon 4 pi epsilon naught works out to be 9 into 10 power 9. It is in MKS. And epsilon naught is called to be the permittivity of free space, and its value is 8.86 into 10 power minus 12 Coulomb square. Epsilon naught being here, Coulomb square per Newton into meter square. This is, dear students, this is the case when the charges are kept in vacuum. What happens if the charges are kept in a medium? Let the charges are kept in a medium having the dielectric constant. A medium is characterized by its dielectric constant, that is written as a capital Q. What is means of that we will discuss just. So, if in a medium having dielectric constant, capital K, then F will be 1 upon 4 pi epsilon naught K into Q1 Q2 over R square. Now this formula becomes F is equal to, or F dash you can say, F dash is equal to 1 upon 4 pi epsilon naught K Q1 Q2 over R square. Now K is called to be the dielectric constant. All the dielectrics are basically the insulators. We will study much about in brief at length when we will be going through the capacitor. Dear students, it becomes F dash is equal to 1 upon 4 pi epsilon naught K Q1 Q2 over R square, where K is called to be the dielectric constant, and the dielectric constant for all except a vacuum, the dielectric constant for all the medium is greater than 1. Okay? Then F will be, F is greater than, or F dash is less than F. Because F dash is equal to F upon K, and K is always greater than 1. So F dash is less than F. Now look here, K is always greater than 1. So F dash is less than F. Dear student, what I have said, the vacuum has the dielectric constant K equal to 1, and all the medium has the dielectric constant value greater than 1, and the maximum value of dielectric constant is for water, and that is approximately 80. The value of dielectric constant for the water is 80. Actually, in fact, this formula, in presence of medium, this formula becomes F dash is equal to 1 upon 4 pi epsilon into Q1 Q2 over R square, where epsilon is equal to epsilon naught into K. Epsilon means permittivity of the medium works out to be That is the product of permittivity of free space multiplied by dielectric constant of that medium. So epsilon or epsilon naught is equal to capital K, you can say. Epsilon or epsilon naught is equal to capital K, means dielectric constant is the ratio of permittivity of that medium divided by permittivity of free space. Dielectric constant of a medium is the ratio of dielectric constant of that medium divided by dielectric constant of free space. Dear students, this is the formula, this is the Newton, this is the Coulomb's law I have discussed with you. What I have said, the two charges, let the two charges Q and Q2 are kept at a distance small r, then the force acting between them would be proportional to the product of charges and inversely proportional to the square of distance between the two charges. And the force works out to be 1 upon 4 pi epsilon naught K Q Q2 r square, and K is called to be the dielectric constant. Dear students, I have said that dielectric constant is what? That is the ratio of permittivity of that medium divided by permittivity of free space. Dear students, the value of K for all the medium is greater than 1, and that is maximum value of K is for water, and that works out to be near about 8. Now, epsilon upon epsilon naught is equal to K. What I have said, let a simple question. I have said that if in air the two charges are kept at r distance away and the force acting is F, and the same two charges are kept in a medium at same distance departed by same distance, then that force F dash would be that is equal to F upon K, means K is greater than 1, so F dash would be less than F, means force acting between the two charges would be reduced when they are kept in a medium. Like, let the two charges are kept in the air and the force are in vacuum, and the force acting between the two charges is 1 Newton. And if the two charges, the same two charges kept in a medium having dielectric constant 6, and they are separated by the same distance as they were present, they were separated in air, then the force will be now 1 by 6. What I am saying, let the two charges are kept at a smaller distance away, that these two charges Q and Q2, and force acting is equal to 1 Newton, and this combination, the same very combination is now kept in a medium having K is equal to 6, then F dash will be F over 6, that is 1 by 6. Means force becomes, if the charges are replaced, charges are kept in a medium, then the force will be reduced by 1 upon K. Dear students, what is dielectric constant? What is the dielectric? That we will discuss at length when we will be studying capacitor. Actually, right now I can only say that dielectrics are insulators, and how they work, what is polarization, polar molecule, non-polar molecule, that a lot we have to discuss, but we will discuss in next class. Now, let's move. Dear students, now we have to discuss Coulomb's law, vector form. What is the vector form of Coulomb's law? Dear students, this is my second video regarding to the electricity, regarding to 12th, you can say. In my first video, that was charge method of charging, based on charge method of charging. In that video, I have told you all, and it was my advice, you can say, that if you want to learn good physics or deep physics, have a concept, and you want to know the concepts of physics, then there are the 3 instruments, and you have to be the master in that instrument. First, you should have a very good knowledge of graph. Second, you should have a good knowledge of calculus, I mean differentiation and integration, basic concepts involved in that, maxima and minima how to find. And third one is that is uh, vector analysis. You should have a very good knowledge of vector analysis. I'm trying to explain a bit. Dear students, Coulomb's law we have to find out in vector form. How? Let the two charges are Q1, Q1. Okay? The two charges are Q1, Q1. Again I am saying the distance, they are separated by distance small r. Now the position of Q1 with respect to origin, the position, if you say the position of a point, position of a charge, it means you are expressing that position with respect to origin. So it is position of this is R1 and position of this charge is R2. The position of two charges are R1 and R2. Now we have to find out the force acting between the two charges applying Coulomb's law. Dear students, what I am very simply, look here please. Now the force acting on charge Q1 due to Q2, the charge, what is charge acting? When you are considering the charge acting on Q1 due to other charge, then you need not to consider that what force is acting on other charges due to Q1. So the force acting on Q1 due to Q2, it would be along the line joining them. It would be along the line joining them. How I am writing? If no sign is given, it means both the charges are positive. This charge will repel this charge along the line joining them. And now the force acting on first charge due to second F12. Okay, the direction F12, I mean the force acting on first due to second charge, and it would be along this line joining these two charges. Now look here, force acting on second due to first, it would be like this. This charge will repel the Q2 along the line joining them, and that would be F21, means force acting on second due to first charge. Okay, dear students, we have to find out F12, the force acting between F12. How I am writing? Look here, F12, that is force acting on first due to second. F12 is equal to 1 upon 4 pi epsilon naught Q1 Q2 over R square. Now R2 is the magnitude of the force. Now we have to describe the direction of force. F12 means acting from 2 to 1, that is from Q2 to Q1. So you can write the direction of force can be written. This very quantity, this is representing the magnitude of the force, a vector having the magnitude as well as the direction. Now the magnitude of the force acting between the first and second charge is this, and now in order to show, because force is a vector quantity, you have to show the direction, and direction can be shown by a unit vector. I am taking expressing the force into two parts. First part is consisting the magnitude and second part is consisting the direction. And direction is from 2 to 1, that is R to 1 cap. This is magnitude and this is the direction. Now dear student, from 2 to 1, that is R to 1 cap. This is vector, the magnitude, you know the vector are the four types. One is a null vector, zero vector, unit vector. Unit vector, I have expressed here the unit vector. Unit vector, a vector which is having the magnitude 1, but it shows only the direction. So this part is consisting of force, the magnitude of the force, and this is the direction. Now dear student, you know vector R is equal to R cap, R vector A is equal to A cap, unit vector, or you can say N cap is equal to vector A upon mod of vector A. Means if a vector is divided by its magnitude, it gives the unit vector of that vector. Unit vector means N cap, you can write vector like this, NA cap. NA cap means It is showing the direction of vector A only. And what is that? Vector A divided by its magnitude represent the direction of vector A only. Now you can say F12 is equal to, in this way, 1 upon 4 pi epsilon naught Q1 Q2 upon R square. R21 you can write vector A upon mod of vector A. So R21 will be vector R21 upon mod of R21. Dear student, mod of R21 is a R. Mod of R21 means distance between 2 and 1. And the same thing, R is representing the same, the distance between 2 and 1. So it becomes 1 upon 4 pi epsilon naught Q1 Q2. You can write it also R21 is mod of R21 is square into R21, that becomes Q. It is also mod of vector R21. Mod of R21 means it is the distance between Q2 and Q1. So both are the same thing. So I have written it mod of vector R21 Q. Now this R21 vector R21. Dear students, now we have to find out what is vector R21. Look here. If R21 is from 2 to 1, make this as R2 is this and R1 is this. From vector law of addition, you know a vector added with another vector result into the resultant, means on the head of a vector the tail of a vector has been drawn, then initial and final positions has been drawn. So it is a resultant of these two. What is the vector law of addition? The tail of a vector is drawn from head of first vector, and then initial and final positions are drawn to meet. Then it gives the resultant of these two. Now dear students, it is R1, vector R1, that is equal to this vector plus this vector. This vector is vector R2, and now you cannot write it vector R only. It is vector addition we are taking. So from 2 to 1, it is R21. So R21 is equal to R1 minus R2 like that. So now again vector R2 plus R21, that is equal to R1. So it will be R1 minus R2, that is equal to R21 is equal to R2 had transformed. So R1 minus R2. Now it becomes F12 is equal to F12, that becomes, dear student, 1 upon 4 pi epsilon naught Q1 Q2 over R21 vector R21 Q. It is R21, you can write it like R1 minus R2. You can write F12 is equal to, dear students, it will become 1 upon 4 pi epsilon naught Q1 Q2 over mod of R1 minus R2 Q into R1 minus R2. This is the F12, force acting on charge Q1 due to Q2. In similar way, we can write, dear student, F12 is the force acting on first due to second charge. Now we can write F21, that is force on second charge due to first, that works out to be 1 upon 4 pi epsilon naught Q1 Q2. It would be R2 minus R1 into R2 minus R1. Dear student, within the mod, either you write R1 minus R2, mod of R1 minus R2, or mod of R2 minus R1. Both are the same thing, because mod of R1 minus R2 or mod of R2 minus R1 means you are considering, it is mod, means you are considering only the distance between Q1 and Q2. Either you consider the distance between Q2 and Q1 or between Q1 and Q2. Both are the same. So mod of R1 minus R2 and mod of R2 minus R1 are same. But look here, in F12 you have got vector R1 minus R2, and in F21 you have got R2 minus vector R2 minus R1. So F12 is equal to minus F21. F12 is what? Force acting on first charge due to second charge. F21 is what? Force acting on second charge due to first charge. Both are equal in magnitude because they are the mutual forces. The force acting between them both are equal but opposite in direction. Like the two charges were Q1 and Q2. Okay, it is the force acting on first due to second, and this is force acting on second due to first. Both the forces are equal but oppositely directed, and this is a mutual force, you can say. This is, dear student, that was the Coulomb's law in vector form. Now let's move further. Dear student, in next topic we will discuss the superposition of forces, or the force acting on a charge due to many of the charges. That is superposition of force, principle of superposition, and the electric field due to point charge, and electric field due to other bodies like ring, disc. So due to sphere, charge sphere, a lot we will discuss. Till then, I hope that if you learn something from this video, then it's my request to you, a request from deep and sincere of my heart. Please like, share and comment my video and subscribe to it. Put the bell icon, press the bell icon so that you can be informed my new video. Soon, very soon, with good number of videos I'm going to make, and I'll try to help you all. Thank you. Bye.